Hey folks, welcome to my channel Number Pen. Today we have two interesting problems on limits, and this is basically to help you understand how to approach the calculation of limit for a series, right? So the question that you have on your screen, or the question one that you have on your screen, is show that limit n tends to infinity, and you have in the numerator 1 plus 2 plus 3 up to n divided by 3n square plus 7n plus 2. Show that this is equal to 1 by 6. And the second problem that we have is show that limit n tends to infinity, 1 square plus 2 square plus 3 square up to 5n square, which is the sum of squares. And when you say 1, 2, 3, remember all of these are natural numbers, right? That's what we have in the numerator, divided by 1 plus 2 plus 3 up to 5n into 2n plus 3. Show that that's equal to 9 by 25. So I want to draw your attention to uh, two important formulas that you might want to remember. Sum of in natural numbers, right? Something that people are quite familiar with. And in case you are not, I would recommend you to remember this particular formula, which is half into n into n plus 1, right? So let's write it in the equation format so that it becomes a lot more easier to represent it. N into n plus 1 divided by 2, right? And similarly, we have sum of squares of n natural numbers, right? And what is that? N into n plus 1 into 2n plus 1 by 6, right? So we will write that as well so that we can readily use it in this particular problem. So let's move to the first problem, which let me copy it here and now paste it out here. So we know that in the numerator of this particular problem, we have the sum of n natural numbers, and we know that the sum of n natural numbers can be written as n into n plus 1 divided by 2, right? And what is that? That's nothing but n square plus n, right? So I'm going to rewrite this as n square n square plus n, and my 2 goes to the denominator, so I copy it as it is. And then I still have my other term, which is 3n square plus 7n plus 2, right? Folks, now I have an expression of the type p by q of n, where n tends to infinity, right? So it is a rational function. And how do we approach these problems, right? Let us observe the degree of the polynomial in the denominator, which is 3n square plus 7n plus 2. And the degree of the polynomial is 2, which means we will divide this expression by n square on the numerator and the denominator and see what happens to this, right? So I'm going to copy this further. So we have n square by n square plus n by n square, right? And my denominator also can be written that way. Let me this first. So I will have 3 n square divided by n square plus 7n divided by n square, and I have 2 divided by n square, right? And remember, I still have my 2, so I retain my 2 and I what I get, right? So I know that my n square by n square becomes 1, and my n by n square with respect to the numerator becomes 1 by n, right? And then when I come to my denominator, just gonna copy this for my n square, and n square gets cancelled in the denominator. So I'm left with 3, and my 7n by n square becomes 7n by 7 by n, and my 2 by n square remains as it is. And remember not to miss out this 2, right? Because these are the mistakes that we usually make. Now we will observe if we have anything further to cancel. I don't see that we have anything further to cancel. So I think we can go ahead and see what we get when we apply n tends to infinity, right? So when n tends to infinity, your first expression, I mean the numerator expression becomes 1 plus 1 by infinity, which is nothing but my 1 plus 0, right? Because 1 divided by infinity is nothing but 0. And then I have 2 into 3 plus 7 by infinity, which makes it 0 again, and then 2 by infinity square, which is again 0. So I have 1 divided by 2 into 3, which is 1 by 6, right? So that's the final answer, and that's what we've been asked to prove as well in the original question, right? So we've been asked to show that the limit of this expression is equal to 1 by 6 as n tends to infinity, right? So that's the solution for problem 1. And let's move on to problem 2, which is slightly more complicated, but it's quite simple as long as you know or are familiar how to find the limits of rational functions, right? So let's use the second formula, which is the sum of squares of n natural numbers, and let's solve this problem. Folks, I just realized that I'd made a small error while copying down the question onto the screen. The mistake is if you go back here, I would have called out that the second problem is 1 square plus 2 square plus 3 square up to 5n square. Show that divided by 1 plus 2 plus 3 up to 5n multiplied by 2n plus 3 equals 9 by 25. And I just realized that, there was a copy paste error while copying down this question onto my screen. It is not exactly 5n, it is 3n, right? So I'm just highlighting the part where I'd gone wrong so that you folks can take a note of it as we go down further into the problem. So the problem that we are going to solve here is limit n tending to infinity 1 square plus 2 square plus 3 square up to 3n the whole square divided by 1 plus 2 plus 3 up to 5n into 2n plus 3. Show that the limit of this expression is 9 by 25. So we've got a sequence in the numerator, we've got a sequence in the denominator. So the one in the numerator is nothing but sum of squares of natural numbers, and the one in the denominator is something similar we saw in the earlier problem. It is nothing but the sum of n natural numbers, right? Except that it is up to 5n. Now, how are we going to modify the two formulas that we have on our screen before we plug them into this particular expression is what we are going to see next, right? Sum of squares of n natural numbers is this. So when we have n extending to 3n, right, which is what we have in the numerator for the sum of squares, all that we need to do is replace n by 3n, right? So I replace n by 3n here, and then I replace 3n here, and then my 2n becomes 2 into 3, which is 6n, right? And so that's what I have here. And similarly, I have for my denominator, I've been asked to calculate 1 plus 2 plus 3 up to 5n. So we know the formula for n natural numbers. So I'm just going to replace n by 5n, and there we have what we need. So 5n becomes 5n into 5n plus 1 divided by 2, right? So now let's plug them into the expression. So I'm going to replace the numerator with this expression, right? I'm going to copy it as it is for the time being, and I'm going to replace the denominator, the one that I've highlighted in yellow, right, which is the sum of natural numbers up to 5n, and I'm going to replace it by this expression, right? And as I rewrite this, folks, I think I can cancel out the numbers 3, 6, and 2, right? So let us do that. So this 3 and this 6, if I'm going to cancel out, I'm left with 2, right? And I've got 2 and 2 in the denominator. So this 2 and this 2 also cancels out, right? So I'm going to remove the numbers 3, 6, and 2 in my subsequent expression. And I'm left with, so we're left with n into 3n plus 1 into 6n plus 1, right? We've cancelled out the numbers, and we still have 5 at the bottom, 5n plus 1 into 2n plus 3, right? I'm going to cancel out the n here, so let's do that. So when I do that, I can remove this n, and I'm left with 3n plus 1 into 6n plus 1 divided by 5 into 5n plus 1 into 2n plus 3, right? So we know that the numerator in this is of degree 2, and so is the denominator is of going to be of degree 2, right? Because when I do a multiplication of 5n plus 1 into 2n plus 3 in the denominator, I'm going to get an expression 10n square plus 3 plus 17n, right? That is what I will get. And you may want to write it that way and solve this problem, or you may solve it from here as you're seeing it on screen, right, without multiplying these individual expressions in the numerator and the denominator separately. So what we do here, so we divide I'm going to copy this expression in the next line. And we have been asked to find limit of n tending to infinity. All that I'm going to do is I'm going to divide the numerator and the denominator by n square, right? Because that's the degree of the denominator that I have. So I have 3n plus 1 into 6n plus 1, 6n plus 1 divided by n square, right? And similarly, I'm going to copy this as it is. Have n square out here, right? So I know that n square equals n into n, right? So all that I do is I can rewrite this expression as 3n plus 1 divided by n, and you'll have to watch me closely out here, into, again I have an expression of this type, 6n plus 1 divided by n, right? And we will write the denominator as well in a very similar fashion. 5 into 5n plus 1 divided by n into 2n plus 3 divided by n, right? So I hope you folks are with me here. Let me close the brackets so that it becomes a lot more easier to visualize this, right? So I'm going to rewrite this expression 3n plus 1 divided by n as 3 plus 1 by n, right? So let me copy this expression and rewrite this, fresh, right? So this is nothing but 3n by n becomes 3 plus 1 by n. And this is nothing but my 6 plus 1 by n. And this one is going to be my 5 plus 1 by n into 2 plus 3 by n. I have my, as n tends to infinity, what happens is my 3 plus 1 by n becomes 3 plus 0, 6 plus 1 by n becomes 6 plus 0, and I have my denominator as 5 into 5 plus 1 by n becomes 5 plus 0, which is 5, and my 2 plus 3 by n becomes 2 plus 3 by infinity, which is 2 plus 0, which is nothing but 2, right? So I have my numerator is 18 and my denominator is 50, which is nothing but 18 by 50, which if I further simplify, I get 9 by 25, right? So that's how we arrive at the solution for this problem. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.